Okay. Okay, should be okay now. From here. Yeah, I'm like, I can hear myself from my iPad, so I'm trying to mute my iPad. Okay. So those are two formula we're familiar with from last PA section, and there's another two, like probably gonna from your high school. Like I'm just gonna put it down. And they are the displacement equal to V naught T plus half AT squared. And the final velocity is equal to the initial velocity. So I'll use V naught as the initial velocity plus AT. And V final square minus V naught square is equal to 2AS. Also velocity is equal to displacement over time. So those are the four equation or the formula we have from last week. And there are some, we cannot minimize the coordinates. And we have two or like four formula for this lecture. They're gonna be new, like probably we're gonna learn that from this lecture or like in this week, but we gotta use them. So VR is equal to R dot, and we're gonna know like what's gonna be the meaning of the dots later. And V theta is equal to R theta dot. The acceleration of R is equal to R double dot minus R theta dot to the power of 2. And A theta is equal to R theta double dot plus 2 times R dot theta dot. Okay, so are you guys familiar with the another coordinate system like the what's it called? No, like the other one. Yeah, polar, yeah. Okay, great. So like usually we use the Cartesian, but now we're gonna like there's some question we're gonna use the polar coordinates, and the R and the theta is gonna be the two like what's it called? Okay, never mind. Like two arrow here for the polar coordinates, one theta and now there's R. So like the R theta, like R dot means the derivative of R. So that means we're doing the derivative over time. And like if we say like we R double dots, that means we're gonna do the derivative 2 times T square and TR square. And like the same thing apply to theta. So theta usually is the angle in the polar coordinates. So theta dot's gonna be like the rate of change of the angle. So it's like usually called it omega, or it's like angular velocity like that. So gonna be the rate of change of the angle, and theta double dot is the acceleration of like angle changing. squared. I'm just checking if this one is recording correctly. Okay, yeah, great. Okay, so those are the formula we're gonna use for our P section today. And then, okay. And then we can go to our first question. Okay, I'm gonna make it smaller. To our first question here. So like, basically we're given the function from 0 second to 4 second, from 4 second to 10 second, and from 10 second to 15 second. So we're given the function between velocity and the time. So like we know the relationship between the velocity and the time, and we're asked to find out the plot for acceleration and the time, and also the displacement and the time. And also like the total displacement means like what's gonna be the displacement when the motorcycle moving from here all the way to here. So like I'm just writing down the known condition from the graph. We know that like from 0 to 4 seconds, we have the velocity is equal to 1.25 t. So that is from here. And from 4 seconds to 10 seconds, we know the velocity got to be a constant. So that is 5 meters per second. And from 10 seconds to 15 seconds, we know the velocity as a function of time is negative t plus 15. Okay, so we have the velocity over time function. So now we can find the acceleration first, because it's for me it's easier. Like remember the acceleration a is equal to dv over dt. So means in order to find the acceleration, we need to do the derivative for like each function over here. Okay, so I'm gonna do it now. So that is for the velocity equation. For the acceleration, like we're just doing the derivative of the, I said that is v1, v2, and v3. So the first acceleration function will be dv1 over dt. And like here, when you do the derivative over t, it's pretty obvious that it's just going to be 1.25 meter per second square and a2. So velocity from 4 seconds to 10 seconds, like you can see, it's a straight line. So that means the acceleration is actually 0 because the speed is not changing. So it's 0. Or like if you do the derivative, like the derivative of a constant value is also 0. So the same thing for V3. Okay. It's negative 1 meter per second square. So here we have the function for acceleration, and then we can do the function for displacement. So the equation we're going to use is the displacement is equal to, we're doing the integral of velocity dt. We're going to do this, and we're simply going to put the boundary on the top and the bottom, and then like solve the math. So for the first equation, like from 0 to 4, like we can see the boundary gonna be, for the time gonna be from 0 second to 4 second. So from 0 second to 4 seconds. And then we know the we know what is the velocity, we know the function of velocity. So just plug in everything 0 to 4, 1.25 T dt. So that is like everything become the mass now, 1.25 over 2 T squared. Yep. And we're evaluating, like we shouldn't put this one there. We're evaluating from 0 to 4 seconds. So like can use a calculator to do the math over here. It's gonna be like very simple, like just put 4 in there. So it's 1.25 over 2 times 4 to the power of 2. And that is equal to 10 meter. Okay, so I'm gonna make this one smaller. So here we have the function for the displacement from 0 second to 4 second. And then the next one gonna be a little tricky. So pay attention over here. Like for the S2, essentially gonna be like this. We're doing the derivative on the left-hand side. Like that is the full equation. Is equal to the integral on the right-hand side, V2 dt. That is S2. So like when we're doing the S1, we are putting the boundary here is from 0 to whatever S is, so like S1. But like now we're doing S2, you couldn't put 0 over here. Like we need to put an actual number here. Because like on here is not starting from 0 displacement. It's actually starting from here. So like the initial value is not gonna be 0. So what's gonna be the value? It's gonna be the value like we found over here. It's gonna be this one. So actually the boundary over here, what we should put is from S1 to, here's S1, S2. So it's like the, on the left-hand side, the boundary gonna be from 10 to S2, and S2 is the one like we're looking for, the S2. So we have to remember to put the S1 over here, because if we forgot, like we're gonna like miss some, gonna get a wrong like answer eventually. And the right-hand side gonna be the same. So time t, like we're doing from 4 seconds to 10 seconds. So that is 4 to 10. And also on here is 4 to 10. And V2 is a constant value, so it's just 5 dt. So like keep simplifying this one. On the left-hand side, we're gonna have S2 minus 10. It's like we put the lower boundary 10 here, and we're gonna get like a minus 10 here. Like otherwise, we're gonna have like, we're gonna miss this 10 and eventually get like a wrong value. So on the right-hand side, that is doing the integration. So it's 5t evaluating from 4 to 10. So what we're gonna have is S2 is equal to 50 minus 20 plus 10. And that is 30. 40. So S2 is equal to 40 meter, and I'm gonna make this one smaller. And this 40 meter means the motorcycle starting from here, go all the way to here. That is 40 meter. And also S1 means go like from the initial point to here is 10 meter. So we know this is 10, this is 40, and we need to find out the last one. So from the initial point, go all the way to 15 seconds was gonna be the displacement. And the procedure is the same. So like just doing the integration from, like this time gonna be from S2 to S3. ds3 is equal to from 10 seconds to 15 seconds. V3 dt. And we know the V3 is negative t plus 15. Like just plugging in the equation, and on the left-hand side, here we have S3 minus S2, and we know the S2 is equal to 40. Let me see. 40, yep. So like solving this equation, we can get on the right-hand side, it's a bit longer now though. Minus 40 is equal to 15 to 10 to 15, yep. So like just plug in the value, 15 to the power of 2 plus 15 times 15 plus 15 and minus, it's going to be a plus at the first, minus 15 times 10 minus 10 plus 40. So like just use a calculator to do that. And eventually you're gonna have 52.5 meter. So now we find out the value. Okay, let's here, make it smaller, over here. 52.5. That means from 0 to 15, the displacement S is equal to 52.5 meter. And this is the answer we are looking for the total distance. So let's see what we have here. We find out the first answer that we need for the total distance. And we're also going to plot the AT diagram and ST diagram. And for the AT diagram, let me see. We already have the function over here. So it's like when t is between 0 to 4 seconds, we have the acceleration 1 is equal to 1.25. When t is between 4 seconds to 10 seconds, we know the acceleration is 0. And from 10 seconds to 15 seconds, the acceleration is equal to -1. So we can just like roughly draw the diagram. See, there's any space. I'm gonna do it here. AT. So x-axis is gonna be the time in second from 0 to 4, 4 to 10, and 10 to 15. And from 0 to 4 is 1.25. And then the acceleration is not gonna change, so 0. I mean, the speed is not gonna change, so acceleration is 0. And from 10 to 15 is -1, so it can be like this. So that is the AT diagram. Yeah, I'm gonna erase those. So I can put this one over here. Okay, so the last one we need to find out is the ST diagram. This one, so we need a function for like 3 time interval for S. Actually, we already solved it over here. So they are just gonna be okay. Actually, we need to change the boundary and I kind of like solve them again. So for the first one, like before, we are just evaluating from 0 to 4 seconds. And now since we need to find a relationship between the time and the displacement, we are not going to set up the boundary from 0 to 4 seconds. Instead, we're gonna set up the boundary from 0 to T1 second. And the T1 on here is gonna be the variable where like the I don't want to say it's the the variable like we need to find. So from 0 to T1 and anything else is gonna be the same. So 0 to T1, 1.25 T. And like just solving this one, we're gonna have S1 is equal to 1.25 over 2 T squared, evaluating from 0 to T1. So just put in the T1 and we're gonna have 1.25 over 2 is equal to 0.625. Yeah, 0.625 T1 squared. So here, like you can see, we find out the relationship between T1 and S1. So that is the first equation. And we're just gonna repeat the same procedure for T2 and S2 and S3. Hope we have enough space on here. Yeah. And also for S2, like remember we need to change the boundary. So like from here gonna be from 10 to S2. The S is equal to from 4 seconds to T2 seconds. T2 seconds. And V dt. So left hand side is the same, S2 minus 10. Right hand side, like we know the velocity on here is equal to 5. I remember, yes, 5. Velocity is constant, is 5. So just like 5t, evaluating from 4 to T2. And S2 minus 10 going to be equal to 5 T2 minus 20. So S2 going to be equal to 5 T2 minus 10. So here we have the second equation with S2 and T2. Then the next one, just the last one, on the same thing, we're evaluating from 40 to the 40. Yeah, 40. Evaluating from 40 to S3. DS3. On the right hand side, in this case, it's from 10 seconds to T30 seconds. VDT. So left hand side is the same as 3 minus 40, and right hand side is also going to be the same. So V here going to be V3 over here is the long one, like the super long one. Negative t plus 15 dt, and doing the integration, the right hand side is what it is going to be. Half t squared plus 15t plus what did I put on here? Plus t. Evaluating from 10 to t3. So just put in t3 and 10 into the equation. And just like doing the math, I don't have enough space here. So I'll just put down the final answer. Gonna be 15t minus 1 over 2t squared minus 60. And I'm gonna make this one smaller. So that is the last equation for t and S3. So we have 1, 2, and 3 for like 3 time interval. Then we can just like draw the diagram. Gonna be the displacement S over time. So for the first line, let's see, the first line is like 0.625 t to the power of 2. So it's gonna be like something like this. Like it's gonna be rough. So it's like in your exam, if you have something like this, just kind of draw the shape, it's obvious. And here it's gonna be 4 seconds. And from 4 seconds to 10 seconds, gonna be our second equation, 5t2 minus time. So should be a straight line like this. And lastly, the last one also gonna be a curve. So a curve like this. So that is 15 seconds. So here's the diagram. And that is our first question. Is it okay for everyone? Yeah, I think it's pretty straightforward for the first one. And also like there's another easy way to do the calculation. So like you can see like we're doing the integral for this line, the blue line, from 0 to 15. And like remember from your math course, the physical meaning of the integral is we're essentially finding the area of this shape. So it's like in exam, if you have something like this, you can just say I'm calculating the area for this triangle and this rectangle and this triangle and then pass them together. That's also the correct answer. Okay, so let's go to the second one. Need to move this one to the right. So like, can I read the question first? We have another motorcycle and it's travel at a constant velocity. So this one is important. It's like one condition we know. So we know like it's constant velocity and V naught. And the V naught here, like it's gonna be a known condition. That's the known. And along the path for a short distance. And we're asked to find out the velocity for V and for X and Y component. So like we're looking for the relationship between Vx and Vy. What I mean by Vx is the velocity going to the right, and Vy is the velocity going up. So on here we have the equation, like we have a relationship between the X and Y. Yeah, X and Y. So that is the displacement relationship. And now we are looking for the velocity relationship. So I'm gonna write down the, like copy down the relationship for X and Y for displacement. And we're looking for the velocity. So simply we're just gonna do the derivative on both sides. Because remember, like the velocity is equal to ds over dt. And we're gonna do the derivative over time on both sides. So on the left-hand side, y just gonna become the by, or like you can do, gonna write it completely. So it's gonna be dy dt. And on the right-hand side, like we're not only doing the derivative for x, we're actually doing the derivative for the whole equation, like for the whole equation here. Like we're doing this. So what we need to write is c sine pi l x. So that means we are doing the derivative of the whole equation on the right, not only x. So keep doing that. On the left-hand side, it's easy. So that is just velocity in y component vy. And on the right-hand side, so like we're doing the derivative for the whole equation and gonna do it one by one. For the c, for this one, c is a constant. So just can, like we can just move it out. And for the parts inside here, we need to apply the chain rule. So just like a very short review about the chain rule. That is from your last math course. Like for this one, we're doing the derivative for sine x. For sine, like remember when I took that course, the professor like to say like we're doing the derivative for sine box. And we're doing this. So the chain rule is we need to find the derivative of sine box first. So that is going to be the cosine box times whatever the derivative for the box. It's going to be like this, or like the box dt. Because the derivative of sine is cosine, and we need to times the derivative of whatever inside this box. So back to our equation. C is a constant, so it's outside now, and sine box, the box on here is the pi over L times X. So the sine become the cosine. Yep. And whatever inside the box, we're gonna do the derivative again. So we need to apply the chain rule again, essentially. So pi over L times X, the derivative of this one is equal to pi over L, like it's a constant. So we need to put the, okay, I'm running out of the color. So this is another small box. So like we need to put the constant for this one outside first. Pi over L cosine, and everything inside. So that is pi over Lx. So that is everything. And then we still need to do the derivative for the x. So gonna be x dot, like the derivative of x, and which is Vx. So like that's the hardest part of this equation, is just finding the derivative of the right-hand side. As long as we get to this point, everything's gonna be easy. So like, can everyone understand what we're doing, like the derivative side? Like maybe you're gonna practice like this kind of thing yourself at home. It's kind of messy over here. Like I didn't explain the math for like 2 years, so. We have this one, and also like, remember from here, we know the motorcycle is traveling with a constant velocity v naught, and the v naught is a known condition. So the second equation we're gonna have is v naught is equal to vx squared plus vy squared, and then square root of that. So we have two equations now. First equation, we have the second equation. And we also have two unknown, like x1, I mean vx and vy. So like just solve this equation or this matrix, we can get the value for vx and vy. So like what I'm going to solve it is, I'll just like square root on both sides for v naught and vx and vy. So what we have is v naught squared is equal to vx squared plus vy squared. And then we have a relationship between the vy and vx. So for this one, I'm just gonna make the right hand side to the power of 2. So v naught squared is equal to vx squared plus everything like in the color, everything colorful gonna be to the power of 2. So I'm gonna put them into a bracket. Sine pi over Lx vx squared. So can keep simplify this one. We have v naught squared is equal to vx squared 1 plus everything inside here, c pi over L cosine pi over L x, and let me see, power signs here, and now the brackets. So Vx, like now we can isolate for Vx. Vx is equal to square root of square 1 plus c pi over L cosine over L to the power of 2. And this one, like we can just write it as is equal to V naught times 1 plus C pi sine pi over Lx to the power of -1 over 2. So here's for Vx and Vy. So like we know what is Vx, we just need to plug in this equation into here to get a Vy. So it's also like just copy down everything. So that is pi, c pi over L cosine pi over Lx. and then everything on the right hand side times C naught 1 plus C pi over L cosine pi over L times X to the power of 1 over, to the power of negative 1 over 2. Okay. So that is Vx and Vy. And again, the hardest point for this question is just the math. It's like you need to do the derivative of this equation correctly. So on the physics side, it's not hard, just the math. Do you have any questions? So the third question, like maybe some of you guys have this like similar question in the high school. So like just gonna repeat the same thing. And for this one, we know like the ball, when the ball is flying, there's only one force, it's just the gravity, like just a gravity. So like when the ball is flying on the horizontal plane, like we're gonna call it X for the horizontal, it's not gonna have any acceleration. And for the vertical plane, vertical axis, like we're gonna call it Y, it's gonna have like an acceleration that is equal to the acceleration of gravity. So it's equal to small g, is equal to 9.81. So we can set up the equation now. Like, you know, the equation for the displacement is equal to V naught t plus half a t squared. So for this one, we can say for Sy, so Sy gonna be the displacement for the vertical in the vertical direction. So in the vertical direction, it's just gonna be from point A to point B, like this one. Like only 1 meter. Gonna be 3 over like 3 minus 2 is equal to 1. So that is 3 minus 2. And that is equal to the initial velocity. What did I call it here? Vax, Vay times the flying time t plus half a t squared. So we can keep simplifying this equation. So on the left hand side, 3 minus 2 is equal to 1. And Vay, that is the unknown, like the first unknown we need to find, times t. T is also an unknown. Plus, or like on here, since like the gravity is pointing downside, and like for now, I'm gonna say like on here, I'm saying pointing upward is positive. So we have like pointing downward acceleration. So in this case, we're gonna use a negative sign. So it's negative half g t to the power of 2. So that is our first equation. So the first equation, basically we're just using the horizontal, the vertical relationship. And the next one, we can use the horizontal relationship. So Sx, so Sx is from this point go all the way to this point. So Sx is equal to VA in x direction times t plus half at squared. So like in this case, since we only have the acceleration in the vertical direction, like in the gravity. So like in horizontal direction, the acceleration on here is 0. So like this equation is just gonna be 10 meter from here, from A to B is like horizontal distance gonna be 10 meter is equal to VAX times T. So now we have our second equation. And the third one, we know an angle on here, 30 degree. So, well, so that is 30 degree. And if we like draw this one bigger as VA, and this one is Vx, and the horizontal one is Vy. Here's 30 degree. So in this geometry, we know tangent theta is equal to VAY over VAX. So that is our third equation. So here, again, it's like we have one unknown, we have two unknown, and we also have the time is the third unknown. Time, where's the time? Time, third unknown. So it's also like third unknown and third equations. So like just solve this equation, then we can get the time t and the speed component on x direction and the y direction. So I'm gonna make it smaller so we have enough space for the mass. Okay, so how I do that, let's see, yep. So essentially it's tangent 30 degree, that is from equation 3, is equal to, on here is VAY over VAX. And then we're gonna put in the VAX and VAY. So for VAX from equation 2, from here we can see VAX is equal to 10 over T. And VAY from equation 1, we can like isolate that. So that is equal to 1 plus half GT squared over T. So the T can cancel out, and tangent 30 degree, like you can use a calculator to find out the value. I remember is this one. I don't quite remember. Just use a calculator. So right hand side, like we can cancel out the T, and then we plug in the G. G is equal to 9.81 square over 10. So like in this case, like everything is known, we just solve for the time T. So time T is equal to 0.987 seconds. So here we get a time T, we can just like plug in the time into our first and the second equation, then we can solve for VAX and VAY. So VAX, oops, is 10 over T, that is 10 over 0.987. So it's 10.13 meter per second. And for VAY, from the first equation, for like the upper part on here, that is 1 plus half 9 times 81 times 0.987 square over 0.987. And that's gonna be 5.85 meter per second. So we have T and AX and AY now. So next one we need to find is like we know the acceleration, I mean the velocity in X and Y component. We just need to like combine them to find the total velocity. So VA is equal to the square root of VAX to the power of 2 plus VAY to the power of 2. So it's 1013 to the power of 2 plus 585 to the power of 2. And the answer gonna be 11.7 meter per second. So here we find the answer for the magnitude of VA. Oh, and another maybe gonna be like a small issue to like just keep in mind is, so for example, here the question is asking for the magnitude of VA. Like in this case, we need to find out what's gonna be the numerical, like what's gonna be a number for VA. So in this case, VA is equal to whatever it was, 11.7 meter per second. But like in some question or like when you are taking exam, maybe the question is asking determine the VA. So it's like, it's not asking only for the magnitude. So like in this case, you need to specify what's gonna be the direction also, like what's gonna be the direction for the velocity. So actually on here it's given is 30 degree. So it's 30 pointing up. Like if the question is asking like determine VA, you need to include the direction. If the question is only asking for the magnitude, you just need to find out like what's the number here. So that is because the velocity is a vector, and like when you're saying calculating or determining a vector, you need to both stating the magnitude and also the direction. Okay, so we find VA, magnitude of VA, that is 11.7. Also, the next one is we need to find the velocity when the basketball passing the basket. So essentially, it's just the horizontal and the vertical speeds at point B, and then we're just gonna do the same together to find the overall resultant velocity. So the velocity at point B direction is just gonna be equal to VAX, because like remember in the horizontal direction, we don't have any acceleration, like we don't have any acceleration, we don't have any force. So the horizontal velocity is gonna be constant, it's not gonna change. And that is equal to 1013 meter per second. But in the vertical direction, the speed gonna change. Vy is equal to the velocity at A in vertical direction minus, like remember we are saying going up is positive. So going down for the gravity is a negative. So it's negative 9.81 times the time t. And we already find the time t on here. So t is equal to 0.987. So VBY that's equal to VAY is 5.85 meter per second minus the rest of parts. Right. So we have a negative velocity now. The negative sign over here means the velocity is pointing downwards. And like if you thinking about the real condition, also makes sense. It's like when you throw a ball, like at the first, the ball gonna flying upwards. And when the ball is actually like going into the basket, it's definitely gonna go downwards. So like when you're like solving some exam or doing your assignments, you always want to make sure it's like the value you find is like kind of makes sense. Like if now we got a positive number, means the ball is also like going upwards. And in that case, like you can see, it's not gonna make sense. Like then you need to like go over your calculation again to see like what's gonna be the problem. So we have VBX and VBY. The next one is just find out the VB. So that is VBX to the power of 2 plus VBY to the power of 2. So 1013 to the power of 2 plus negative 3.8 to the power of 2. So the final answer is 1083 meter per second. So that is the magnitude of VB. Then we can look back. So here, like we can see, it's asking the velocity when they pass through the basket, like just saying finding the velocity. So in this case, it's not saying the magnitude of the velocity. We need to find out what's going to be the angle for the velocity at B also. So we have to find theta B. And just like before, theta B is equal to, or like we can say, tangent theta B is equal to VBY, right, over VBX. So like you have to use a calculator to find out what is VP, tangent to the power of -1, 3.83 over 10.14. And that is equal to 20.7 degrees. So like in order to have maybe like if this one is a question in exam and it's asking to find out what is the velocity of B at point B, what is VB? This one gonna be like half point, like maybe 0.5 mark, and this one gonna be another 0.5 mark. So you need to do both to get a full mark. Do we have any question? Okay, so next one. So actually there's some like small issue with this question. If you try to do that at home, then you'll find out like the math is gonna be impossible to solve like by hand. But like now I'm just gonna like show the physics part. So we have the relationship between the acceleration and the time again. And we're going to find out the magnitude of the velocity and the acceleration. So that means we only need the magnitude. We don't need to like worry about the angle when the car has traveled as equal to 80 meters from the rest. So the equation gonna be again, S is equal to the integral of v dt, and v is equal to the integral of a dt. Like we know what is the relationship between a and t, and then we just need to find the displacement. So we're gonna do the integration twice. So like s equal to this one, v is equal to this one. So s is equal to integration. We're gonna put the v into here. So we're gonna have a double integral a dt. And also a is a number that, is an equation that is given. So s gonna be equal to double integral 0.5 e to the power of t dt. And here, like we're gonna fill out the boundary. So the boundary gonna be from 0 second to t second, 0 second to t second on both. And then just gonna solve the integration here. Like just solve it twice. So the first time is from 0 second, like 0 to t. And the integration of 0.5 e to the t, that is 0.5 e to the t minus 0.5 dt. And then we're gonna solve this one second time. So that is e to the t minus t and minus 1. For this question, don't worry about the math. Like you just need to do you just need to know we're doing the integration twice, because we're gonna see there's a problem with the math now. So we have this equation now, and then we know the s, like it's saying when the car travel s equal to 18 meters. So we're gonna put 18 over here. So 18 is equal to 0.5 e to the t minus 1. And then we're gonna solve for t. So what we're gonna have on here is 37 is equal to e to the t minus t. So for this equation, at least for me, I cannot find a way to solve it by hand. If you guys know how to do that by hand, that would be perfect. But for me, I'm just doing that on MATLAB. So actually, let me show you. So that is the way I solve it. So basically, I just plot the function first. Actually, on here, you can see the curve is the function, and we need to find out what's gonna be the intersection point on here when the s value or when the y value is equal to 0. So we need to find the point on here, and if we zoom in, we can see it's a value between 3 and 4. And eventually what I did is I'm finding the intersection point. So this function means the intersection point between 3.5 and 4. And just simply run this one and gonna return an answer 3.7. You're gonna know this, you're gonna learn this in your second year's Ecor1048, remember? So if you don't understand what I'm doing here, it's all good. You won't have this in exam. It's doesn't make sense to have this in the exam. Well, unless the professor allow you guys to use MATLAB, but that's not gonna happen. Okay, so let's go back on here. So like anyway, we find out what's the value of t now. So t is equal to what? 3.7064 seconds. And then the next step is going to be easy again. So we have the time t, and we're asking to determine the velocity and acceleration. So just like use the equation again. So like here we know velocity is equal to derivative of a, I mean the integration of a dt. So that is evaluating from 0 to t seconds of a, and a is also given is 0.5 times e to the power of t minus 1 dt. So v is equal to solving the integration inside, go to 0.5. Well, actually, this integration. So it's gonna be this one evaluating from 0 to t. E to the power of, we found a t that is 3.706 7064 minus 1. So this one is going to be 19.85 meter per second. So that is the velocity of the vehicle when it passes this point. Like we have a velocity pointing this way, like a, or we can call it like a tangential velocity going this way. And now we need to find the acceleration. So actually there are going to be two acceleration since the car is like moving along a circle. We're going to have a acceleration that is tangent to the circle, and we're also going to have another acceleration like pointing inside the centripetal acceleration. So we can find it like one by one. For the centripetal acceleration, or like this case, we call the acceleration that is normal to the moving path. So an, that is equal to the velocity to the power of 2 over the radius, over this one, the radius of the circle. Like here, they use rho, so it's rho here, and then just put in number 1985 to the power of 2 over rho, that is 30. So you're gonna get 13.14 meter per second square. And for the tangential velocity, we are just gonna like do the integration again, like just like the left hand side. Wait, you don't need to do the acceleration, integration. It's already given. It's already given on here. So the tangential acceleration is equal to 0.5 times e to the power of t, and t is 3.7064 seconds. So just solving this one with a calculator, and that is 2035 meter per second square. So now we have the normal acceleration, and we have the tangential acceleration. The next one, we're just gonna combine them together to get our final answer. 1314 to the power of 2 plus 2035 to the power of 2. So this one, the final answer is 24.2 meter per second square. Like just a reminder, this one is by MATLAB. So that is the solution for this question. Are we agreed on this? Okay, next one. So this one is gonna be very easy. Why my computer is frozen. So like we're gonna use the equation we mentioned above. Like the trick is when you see the question is like stating when the question is stating the condition like this, like in theta dots, theta double dots, or like in R, maybe like R dot, R double dot. When you see those things like in a question, you wanna like directly think of the formula for those for like theta dot, velocity theta, and like in AR, and also you wanna like use those like try to use those equation first. Like usually they like you're gonna use those equation to solve for this question easily. Okay, I'm why those like squeezed together. So back to here, we're gonna use the equation I mentioned above, mentioned before. So let's see. Determine the magnitude. So again, it's magnitude again. We don't need to worry about the angle. Yeah, we don't need to worry about the angle of the velocity and the acceleration. Then the R is equal to 1.5. So essentially we're finding the velocity and acceleration. And in our equation, we know that the velocity VR, like I'm just copying down the equation, is equal to R dot V theta is equal to R times theta dot. And also like, of course, for the resultant velocity, it's gonna be the sum of these two velocity plus V theta square. So that is the resulting velocity. And for the acceleration, it's also like given by the equation. R double dot minus R theta dot to the power of 2, and A theta is equal to R theta double dot plus 2 times R theta dot times R dot theta dot. And also the resulting acceleration is the sum of these two acceleration. Okay, so like essentially you just need to find out what is R dot, what is theta dot, and what is theta double dot. Okay, so now we can make a list. So we know R is equal to 1.5 meter. And are we given R dot? So R dot, let me see. R dot is given over here. So there's a constant rate of 3 meters per second. So R dot is 3 meters per second. And R double dot. So in the question, like it didn't say anything about R double dot. Like it didn't say anything about the acceleration. So it's just 0. And for the theta, like the theta itself is like it doesn't mention, so it's just 0. And theta dot is given on here, 2 radian per second. Theta double dot is also a given value is 3 radian per second square. Okay, so now we have like everything r dot, r double dot, theta, theta dot, and theta double dot. Like we're just gonna plug in those values into the equation and then we can get the answer. So just math again. Okay, so now we can see VR is equal to R dot is equal to 3. V theta is equal to R theta dot is equal to 1.5 times 2 is equal to 3. And AR is equal to 0 because R double dot here is 0 minus 1.5 times theta dot to the power of 2. So 1.5 times 4, that is 6. And A theta is equal to R times, R is 1.5 times theta double dot is 3 plus 2 times R dot is 3 times theta dot is 2. So this one is 16.5. Okay, so for the velocity, resulting velocity is VR square plus V theta square. And since they're the same value, so it's just gonna be 3. And for the A, it's also gonna be A R square plus A theta square, and that is 6 to the power of 2 plus 16.5 to the power of 2. And we have 17.6 meter per second square. Okay, so is it the final answer? Yeah. So that is the final answer. Like you just need to find out what's gonna be the equation for this question, and then like just find out the value and plug in a number. It's very simple. Can we move to the next one? I'm just gonna drink some water. So this one, we have a box moving on the parabola. And the equation for the parabola is also given. Y is equal to 0.4 x to the power of 2. And we're going to find out the magnitude again. So we don't need to worry about the angle. So we are finding the magnitude of the acceleration when the box is at this location. So that is when x equal to 2 meter and y equal to 1.6 meter. 1.6. The magnitude and these. So for like any particle moving on the curve, when we are talking about the acceleration, we always need to consider about the tangential acceleration and the normal acceleration. So even for this one, like there's two acceleration. One is the acceleration pointing downwards. It's like actually changing the speed of this particle. Another acceleration is the acceleration actually changing the direction, like the moving direction for this box. So like it's gonna be in the normal direction, like normal to the surface of the curvature. Okay, so like we know the velocity is equal to 8 meters per second. So it's over here. It's a given value. And the tangential velocity is equal to v squared over r. And r is the curvature of the surface. So we need to use another equation to find out what's going to be the curvature of the surface at this location. And the formula is also given in your lecture slide. So like here, I'm just going to copy the equation down. So the curvature, like sometimes use rho or sometimes use r, is equal to these to the power of 2. Yeah, just doing the second double derivative of x over y, and on the above is 1 plus the derivative of the curvature equation to the power of 2, and then everything to the power of 3 over 2. And then we're just evaluating when x is equal to whatever number you want. So like in this case, we're solving this point. So we have x is equal to 2 meters. So also from this equation, you can see that like the curvature for this surface is gonna change like every time when x gonna change. So like first we're gonna find out what's the curvature for r. And this one is it's just the equation. Gonna move it above. So here I'm just gonna plug in the value. We have y equal to 0.4 x to the power of 2. So on the above is equal to 0.8 x 2, and everything to the power of 3 over 2. On the bottom side is equal to 0.8 because x gonna disappear. And then evaluating when x is equal to 2. So that means plugging x equal to 2. So it's going to be 1 plus 0.8 times 2. So better times 2 to the power of 2 to the power of 3 over 2 over 0.8. And then just use a calculator to find this one. The answer gonna be 396. So now we can know what is gonna be the AT. So that is gonna be a to the power of 2, that is velocity to the power of 2 over the curvature. The number we found here is 8.396. So the final answer is 7.622 meter per second square. So now we find the 10. But actually, this one should be a normal acceleration. So now we get the number for the normal acceleration and the number for the tangential acceleration is given on here. So dv, like remember, dv over dt is just the acceleration, is equal to a. So simply just state that the tangential acceleration at this point is equal to 4 meters per second square. So here we have normal and the tangential. The resultant acceleration is again normal to the power of 2 plus tangential to the power of 2, and it's equal to 7.622 to the power of 2 plus 4 to the power of 2. That is equal to 8.61 meter per second square. So like for this one, I think it's also pretty straightforward. The only thing is you need to know how to find the curvature of this surface. Like this equation is also given, so shouldn't be too hard. Okay, so our last question is a motorcycle again moving along this this path, and when the motorcycle is at 0.8, you know the velocity is 40 meters per second, and we also know the acceleration over displacement function. But actually the S over here, like the question should be more specific. So the S on here is the distance that the car, that the motorcycle travel. Like if you have some question like this in the exam and you're not very sure about the S is the displacement or like the total distance that the vehicle or any particle travels, you can just ask like whoever is like monitoring the exam. Because like for this one, if S is the displacement, it's gonna be way different. Like if S is the displacement from A to B, it should be like this. But eventually, like we're calculating the curve. So this one is the S we want here, but not this one. Like that is, I guess, like a small mistake in the question. Okay, so this one essentially just the acceleration is equal to negative 0.05 times S. And then we're going to find out the speed and the acceleration. So the formula we're gonna use for this one is gonna be A ds. Since we know what is A and what is S, is equal to V dV. So we're gonna use this one, like we're finding the V. First, we're finding the speed. First, so we have the equation here. We just need to set up the boundary. So like on the, let me see what did I write here. On the right hand side, we are solving from 40 to the velocity that we're looking for, because 40 is on here is the initial velocity. So this one is the initial velocity. So that is the lower boundary from the initial velocity to the final velocity. So this one is the final velocity, which is an unknown now. And on the left-hand side, we're just evaluating from 0 to, for 0, like 0 is the displacement or like the distance that the motorcycle travel at the very beginning to the distance that the motorcycle travel at the end. So from 0 to the final S. And then we can just simplify the equation on the right hand side. That is just half v to the power of 2 v squared. So evaluating from 40 to v. And on the left hand side, it's going to be from 0 to s. And the value, like, you need to find out what is the s for this curve. So it's going to be 2 pi r times 360, 60 over 360. So that is the equation to find out this one, just the geometry. And the acceleration is given is equal to negative 0.05 s ds. So again, moving this one up. So on the right hand side, it's just going to be half v squared minus half 40 squared. On the left hand side, the integration of the things inside is 0.05, negative 0.05 over 2 s to the power of 2, evaluating from 0 to here. So that is 50 pi. And on the right hand side, it's going to be the same, like it's just solving the math. So on the left hand side, it's also just going to be solving the math. 25 times 50 pi to the power of 2. So like just simplify this equation. We should get velocity is equal to 13 meter per second. So now we find out the velocity for the motorcycle when they reach point B. And then we need to find the acceleration. So that should be VP. And like for any particle moving on the curve, when we are going to calculate the acceleration, just don't forget about the normal acceleration or the centripetal acceleration. So also for this motorcycle, we need to find out what is AT, like tangential acceleration. And also we need to find out what is the normal acceleration. And usually normal acceleration is easier to find because it's just going to be v squared over r. And we already find that it's 19.13. And the r is a constant value here. So it's 150 meter. So the normal acceleration is going to be 2.44 meter per second square. And the tangential acceleration, so let me see. So that is just going to be r times theta, like from the previous one. And so it's gonna be 50 pi times 0.05. Wait, it's not this one. It's actually given here, sorry. It's a given function. So just 0.05 times s. S on here is 50 pi. We already find the s on here. This one's s. So just like plug into the equation on here. We can get this one is equal to 2.5 pi. And the acceleration A is equal to put them together. (2.44 to the power of 2 plus 2.5 pi to the power of 2). So that is equal to 8.22 meter per second square. So that is the magnitude for the acceleration. And can you guys see what are we missing now? Like the question is asking for the acceleration and the velocity. Yeah, so we're missing the direction. Like we need to find the speed and the acceleration, but we only find the magnitude. We need to find what's going to be the angle. So on here, the angle tangent theta is equal to the normal acceleration over the tangential acceleration. So it's 2.44 over 2.5 pi. And then just use a calculator to do the math. So here's the angle or the direction. And that is gonna be the final answer, like the full solution for our last question. So about like the significant figures doesn't really matter. Yeah, so it doesn't matter. Yes. So just two things keep in mind is like when you have a particle is moving along a curve or like it's not moving along a straight line, remember to calculate the normal acceleration. And also when the question is asking the acceleration or the velocity, you always want to keep in mind like, do you actually need to calculate the direction? It's like when the particle is moving a straight line, normally you don't need to like calculate the angle because it's like pretty obvious. It's just going to the right or going to the left. But like when the particle is moving along a curve, you need to like specify or like calculate what's going to be the angle. So this one, like you can imagine, is a perfect circle. And then for 2 pi r is equal to like the, I forgot its name again, like it's gonna be equal to the surface, I mean, the length of the circle, and like 360, 60 over 360 is only like this segment. So that is what like 60 over 360 comes from. Final acceleration is not same as 2 pi over 360 times 150. So where is 150? Oh, it's the radius. Well, for this one, like 2 pi 150 times 60 over 60. So 60, like this one is finding the S or finding the travel distance. These dots. Oh, because like, as I mentioned above, like we're using this equation in the light blue to find out the tangential velocity only. And then we need to use, like there's another part of the acceleration that is like normal to the surface. So there's another normal acceleration, which is equal to v squared over r. So that is another part of acceleration. And then you need to put two acceleration together to get the final acceleration. Yeah, so that is what I mean by when you're doing a calculation about particles moving on a non-straight surface, you need to keep in mind, remember calculating the normal acceleration. Okay, so I think I can stop the recording.